Okay, so I've had a request to talk about some of the machines that I'm using to print the drone. So this is the drone we're talking about. So it's a fully 3D printed drone. It's got carbon fiber arms. So I've got a number of machines that they're being used for a few different reasons. So I'll just start from the left-hand side and kind of work my way across. So this is a Mark Forged. So it's, if I can find one of the parts. So it is used for printing the motor mounts, or I've been using it to print a few other parts throughout the process, but this is a motor mount. So you can get a little bit of extra strength performance out of a Mark Forge. It uses a slightly different printing process. It's got an additional, it has an additional reel. So this reel here is continuous carbon fiber and it feeds through an additional nozzle. So it has the ability to print not only the filament, which is in this, it's a nylon filament in that dry box, but also a continuous, a continuous fiber as well. So it's, 3D printed nylon parts are actually quite strong. But with continuous carbon fiber reinforcement, they're very, very strong. So you probably be roughly 4 times stronger with continuous carbon fiber. It's not necessarily necessary for all builds, but it can just give you a bit more headway if you if you crash your drone a little bit, which I do. So it's good for me. So then we've got some 2 P1Ss. Most people will probably recognize these machines. On the left, I've got this one set up printing only TPE. It only ever prints TPE. That's what we're printing the nose cone from. So it's a flexible material. This TPE is pretty soft. So it needs to be to try and limit the vibration transferring into the camera. And I've got that set up with a 0.6 millimeter nozzle. And because it's so soft, I just use this, it's kind of janky, but I just use a reel basically hovering over the top. Feeding directly into the extruder. That's a pretty common setup for a TPE. So that just prints nose cones, 0.6 millimeter nozzle, never changes. Engineering build plate. Excuse me. So next machine, same thing, P1S, engineering build plate. It's a 0.4 millimeter hardened steel nozzle. It's usually printing fiber on, but I've got that in the the drying oven at the moment because that doesn't seal very well. So I just whenever I'm not actively printing, I'll take the filament out of there and just stick it in the oven. Here's one of the chassis that it's printed. P1Ss are absolutely goated. I really, for their value for money, there's nothing that comes close. They are one of the best printers to ever have been released to the market, and I highly recommend that. I use this 10 times more than I use that, and it's just because it's so straightforward and reliable. So the next machine is H2D. So I've only had this for probably about, I don't know, maybe a month and a half or something like that. It's a dual nozzle machine. It's definitely in that sort of next tier up. I've been using it to experiment with supports. I've got this set up with I've got an upgraded cooling or heat break fan on it, and I've got an emergency stop, just a bit more of a kind of industrial focus for the machine. I'm using the AMS for the right hand nozzle, and then I'm using a filament dry box for the left hand side. So this is a sealed dry box. I've got a humidity gauge on it, and I dry the filament in my drying oven, and then I drop it in this dry box and just print from that dry box. So I've been using this to print the battery cases. So that's one of the battery cases. It's a 6S, takes 21,700 cells. So yeah, that's working really well as a PETG supported part. Just gives it that little extra sort of crispness on some of the supported parts. I've also got a BQ or BI BIQU. I think it's a Glacier build plate. So that's that's just to help get adhesion with nylon and ASA or PETG. So I'm still experimenting with this. Look, you can see the supports have actually just fallen off on this print, which is perfect timing. So I'm going to go ahead and stop that literally right now. And we'll do that again. That's why I've been using PETG. Classic. So anyway, great machine. I'm still learning how to use it, and we'll definitely continue that program. So this machine is it's an Asiga SLA machine. It's basically a resin printer. So I'm using this to print the top covers that's been painted. But this is because the top covers are really fine. It's got a lot of fine features, very thin wall. And FDM's excellent for functional parts these days with good nylon materials. But SLA, you cannot come close to its to its feature detail. So it's able to these parts are off the Asiga. They're basically beautiful. I don't have to sand them down. I just wash them in an ultrasonic resin bath, and they're ready to be painted. So that's just straight off the machine. It's just incredibly detailed. It's a really cool thing. So this is it's an industrial grade machine. It uses a really large projector DLP source, and then it has a large crystal plate underneath here and a machine steel carrier plate, and it can print its full volume in about 6 hours. So it's a very fast machine too. So I'll get five of those covers every 6 hours out of it. So this is by far the most expensive machine I have. It's sick hardware. There's probably better value options, but I just really wanted something that was very high fidelity and resolution. So that's what I ended up going for. Excuse me, I'm still a little bit sick, so I'm coughing. But that's basically the overview. Asiga Pro 4K, H2D with a few little upgrades, P1Ss, and a Mark Forge Mark II.